Okay, so in step 9, identify presence points. Now, after the values that specify presence locations from two data sources that have been added, the common presence locations in both data sources can be identified. In this step, you use the attribute table to select where maize is present in both raster datasets to create a new field in the attribute table. Using more than one dataset to identify locations that are suitable for maize helps minimize error in your data. In the presence point attribute table, click the select by attributes. So let's go ahead and do that. So this is a presence point. Right click and then go to attribute table. Attribute table. So we're going to click on this select by attributes. Okay. So here it is. We have you create write an expression to identify points where maize is present in both datasets as indicated by the value 1. So create a clause that states where gfsad underscore maize is equal to 1 and spam maize is equal to 1. So let's create that expression. New expression. Click here. Is equal to. Just type 1. Add clause. Spam maize is equal to 1. Right. So that's it. What else again? Okay, click apply and then click OK. So let's check whether this is equal to raise. Apply and then OK. So zoom to the presence points layer. Okay. So click OK. Then just right click on this and say zoom to layer. Alright, so you can see that. Then what's next? You have it like so. 8,693 records. Okay, the map and attribute table updates to highlight the selected points. The selected points represent the points where maize is present in both the GFSAD layer and the spam layer. To save the selection, you will calculate a new field. On the review, and click the table tab in the tools group. Click calculate field for name. Type maize present. For that, I can always click on calculate here. Okay, so we'll type maize present here. Sorry. For field type, choose short integer. Short 16-bit integer. So field type short. 16-bit integer. Under maize present is equal to type 1. Just type 1. Then click apply and then click OK to close the calculate field. So we're going to click apply. So click OK. Then what next? A new field called maize present is created. This field combines the points identifying where maize is present in both the spam and GFSAD layer. You now switch the selection in the attribute table to calculate the selected fields that should be 0 to reflect the points in both layers where maize is not present. So in the attribute table, click the switch selection button, calculate field again, then under maize present, delete 1 and type 0. Okay, so we'll go look at the switch selection button. click on it, and then the opposite selection, right? No problem, just go ahead and click on the attribute calculate, and maize present. I will just type 0, and then we'll click on apply, and we'll click on OK. Okay, I've created a new field in the presence point attribute table that identifies where maize is present in both the SPM and GFSAD raster datasets. Click the clear selection button and close the attribute table. Save your project. So is it here? I don't see it here. Okay. Save your project, right? So extract baseline climate data. The final step in creating a training dataset for presence only prediction model is to add explanatory variables. Add baseline data to presence point. Okay, so in this step you add the baseline climate variables for each presence point to complete the training data sets for your prediction model. You use the extract multi-values to point tool to add these variables to your presence points layer. Because you previously ran the extract multi-values to points tool, it is still open in your processing pane. You simply need to remove the GFSAD maize and spam maize layer before running the tool again with the new parameters. In the geoprocessing pane, for input point features, ensure the presence point is selected. Under input raster, point to GFSAD maize and click the red X to remove the layers shown in the following graphics. This is the same process to remove spam maize. Now add the baseline by climate variables to the tool. Okay, so let's do that. Value points to variables. Okay, I've already gone back. I need to fire up that again. So okay, so on the left on the project, click folder, then double click the maize prediction modeling folder. So let's do that. For input raster, I'm going to click on the browse button, and let's locate that folder, right? Click on folders. Okay, where is baseline by okay, by climate variable folders. Okay, here we are. Then click baseline by climate 01 CRF, press shift key and click baseline by climate 19.crf to select all the files. So let me see screenshot. Okay, by climate variables. Okay, I have two different folders here. One, hold on the shifts. Let me check the screenshot. On the screenshot, there's no subfolder within, so I need to unselect that. Okay. Click OK to add the selected baseline by climate variables to input raster. And then click run. Okay. We are going to run. So let me pause this video while it runs. Okay, Okay, so the tool has finished running and we can see that all the baseline bioclimate variables have been added to our attribute table. We have baseline climate 0, 1, 2, 3 up to 19 of them. Okay, we can close this. The 19 baseline bioclimate variables are added to the present point attribute table. This baseline bioclimate variable has a value that is associated to a point. These values are based on different calculation methods for each variable. The amount of a value that is present in the location of the point is the value that is added to the attribute table. For example, some points may have a value of 0 as a baseline bioclimate variable. Value of 0 means that the baseline bioclimate variable has no effect on the location of the point. For more information on the calculation methods for the bioclimate variables, see the United States Geological Survey (USGS) publication Bioclimate Predictors for supporting ecological applications in the contaminous United States. Close the attribute table, save your project. In this exercise, you created a training point dataset for your prediction model by first identifying areas of known maize presence in the region of sub-Saharan Africa based on two raster datasets, then combining 19 baseline bioclimate variables to incorporate explanatory variables. If you continue to next exercise, leave ArcGIS Pro open, otherwise exit ArcGIS Pro. Okay, so let's go to the next exercise. Let's save our project. Okay, so this is the next exercise. In many parts of Africa, food and income security are tied to the agricultural production of maize. However, as a result of climate change and its related impacts, food security for many vulnerable populations is diminishing. In the previous exercise, you prepared a training dataset for the presence-only prediction maxing tool, which will be used to model current and future stability using baseline variable against the SSP3 7.0 climate scenario for 2055. After a trained dataset of present points and the explanatory variable is created, a model is ready to be trained. And once trained, the model can be run using projected explanatory variables to predict the future. Scenario: imagine the following scenario. You are continuing your work as a GIS analyst for a global non-profit organization in Africa. As part of the agricultural minister's efforts to protect farmers and safeguard food security, you want to use your training data set for the presence only prediction max int tool to create an output that models future maize suitability. In the previous exercise, you completed the prepare presence data step of the workflow to prepare your training dataset. Therefore, in this exercise, your task is to complete the remaining steps. Create prediction points, train the model, run the model to predict maize suitability in Africa, finally review the model diagnostics and results of your model. So here is the flowchart: prepare presence data, create prediction points, train model, run model, review model diagnostics, and then review results. So after preparing your presence data, you will complete the workflow for your presence only prediction model. Depending on your computer's hardware, running the prediction model could take up to 20 minutes. For this reason, you may choose to not run the model during the exercise and instead, where instructed, use the provided results files. Okay, but don't worry, I'll run it. First, you will create the prediction points required to run your model. Predict spatial pattern change. How can I predict? Okay, a training dataset is used to teach a model to perform a task such as prediction. To train a model, you must first run the tool using the training dataset and baseline explanatory variables. To create a presence only prediction model, you must then run the tool a second time using prediction points and future explanatory variables. Okay, in this step, you create the prediction points for your model. If necessary, open Maize modeling. Okay, in the contents pane, turn off the presence points layer. Let's quickly do that. I've done that. This presence pane, search for an open extract by mask Spatial Analyst tool. Let's do that. For input raster, choose GFSAD Maize. This is Raster-based Spatial Analyst tool. Okay. That's for input raster. Choose this. For input raster official marks data, choose study area. Study area. Then for output raster, type GFSAD underscore maize underscore clip. GFSAD underscore okay. Leave the remaining default parameters and click run. So click on run. Okay, so the tool has finished running. That's it. So you have defined a study area for your prediction points by clipping the GFSAD underscore maize layer to only the region of Africa that is your study area. Now you can create the prediction points for your study area using the GFSAD maize clip layer. You use the GFSAD maize clip layer to create a point for each pixel or cell of the raster layer. Each cell in the GFSAD layer measures 1 square kilometers. This region of Africa measures approximately 5.2 million square kilometers. Therefore, by converting your raster layer to points, you will end up with approximately 5.2 million, 5,200,000 points. This conversion may take a few minutes to process in ArcGIS depending on your computer's processing power. In the geoprocessing pane, search for an open raster to point conversion tool. Okay, raster to point. Okay, that's it. For input raster, choose ZFSAD underscore maize underscore clip. Okay. For fields, confirm that value is selected. Okay, select. For output point features, type prediction points. Okay. At the bottom of the map, click the pause drawing button. Okay, at the bottom of the map, click the pause drawing button. So let me see. Am I going to see it here? Let me check for it here. I've seen it. Look at the pause drawing. Paused. Okay. By pausing the map display, you can run the tool but not draw the 5.2 million points on the map. Okay, you only need the points as input for the model. Okay, you need the points as source input for the model. You do not need to visualize them on the map. Okay, that's this pause. Okay, so click run. After the tool finishes running, the context will turn off the prediction points layer. At the bottom of the map, click the pause drawing button again to resume the map display. You have created the prediction point for your presence only prediction model. Save your project. Okay, let's click on run now. Run. Because the tool has finished running, so we'll turn this off, and then we'll come here and then we'll pause it. So click on Save. So next we enter step 2, add bioclimate data to prediction points. Sorry. After creating prediction points for the presence only prediction model, explanatory variables need to be added to each point. The training dataset only uses baseline variables as explanatory variables to establish the baseline presence for the model. The dataset used for prediction uses both baseline and projected variables so that the model can predict future suitability. In this step, you will finalize your presence points by adding both the baseline bioclimate variables and the projected bioclimate variables from the climate scenario for 2055. To create the training datasets, you will use the same workflow that you used to extract the baseline bioclimate variable values to your presence point. So in the processing pane, search for and open the extract multi-values to points Spatial Analyst tool. Extract multi-value to point. Okay. Spatial Analyst tool. So for input point feature, choose prediction points. Prediction points. For input raster, click the browse button on the left. Add projects, click folders and double click the Maize prediction modeling folder. Double click baseline by climate variables folder. Click baseline bioclimate 01.crf. Press shift on your keyboard and then click OK to select the 19. Alright, so before doing that, let me just go ahead and open the attribute table here. Let me see what I'm working with. So currently the attribute table only have object, shape, point ID and grid code. Okay, so we're going to click on browse here, click on folders, back here baseline bioclimate 1.crf, then scroll down to the last one, hold down shift and then click the last one. Okay, click OK. I've added all 19 baseline bioclimate variables. Next, you will add a bioclimate variable for 2055. In the geoprocessing pane, scroll to the bottom of the input raster list. In the empty row, click the browse button as is indicated in the following graphics. Okay. In the input raster dialog box, go to the bioclimate projection variables 2025. Okay. Okay, let's do that. So click this folders. So which of the folders are we going to? Before that, double click Maize prediction and then bioclimate projection variable 2055. Projection variable 2055. Okay. Click bioclimate projections 01 2055.crf. Press shift on your keyboard and click bioclimate 19. That means you're selecting all 19 again. Okay. All the baseline and projected bioclimate variables are added to the geoprocessing pane. Adding all the bioclimate variables to the prediction points, you have a complete prediction points layer to model fusion Maize suitability using the presence only prediction max ends tool. Running the extract multi-values to point tool can take a few minutes depending on the computer's processing power. Click run. So let's click on run. The prediction points layer now contains all the necessary bioclimate variables and is ready for your prediction model. Turn off the gfsad_maize click play and save your project. And step 3 is to train the model. Let me see how many steps more. Train the model, then run the prediction model. That's step 4. And then step 5, review model diagnostics. I think that's all. Convert point features to raster. Okay, that would be all. So let's go back to our step 3. Okay, so the tool has finished running and we can see the prediction point now carries information about the 19 bioclimate variables. You can see them, right? Let's see. Okay, alright, so so we should turn this off and we should save our map. Okay, step 3, train the prediction model. So before performing the prediction, the model must be trained using the baseline variables. Train the model. In this step, you will train the model using the training dataset, which include the Maize presence points with the baseline bioclimate variables. The geoprocessing pane search for an open presence only prediction. Marks it presence only prediction. Okay. Okay. So you click on the tool. Spatial statistics tool. The input point features are the known areas of Maize presence in the training dataset that you created for the study area. Because you already prepared your data by classifying values to identify where Maize is present, you can enable an option to indicate that the training point dataset contains background points. For input point features, choose presence points. Okay, here it is. Then for input point features, choose presence points. So you just choose that presence points, and then check the box for contain background points. Contain background points. For presence indicator field, choose the Maize presence. Maize presence, where are you? Here it is. To train the model, you will use 19 baseline bioclimate variables as the explanatory training variables. Under explanatory training variables, click the add menu button. Explanatory training variables, okay. Add menu button, and then check the box for each of the 19 baseline bioclimate variables and click add. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 16, 17, 18, 19. Okay. So these are the 19, and then click on add. You have added the baseline bioclimate variables to train the model. Now set the explanatory variable expansion as special tiny parameters. The explanatory variable expansions parameters specifies the basis function to be used to transform the explanatory variables for the model. Basis functions incorporate intricate relationship forms into the model. If multiple basis functions are selected, the tool will run through all of them and use the variable that creates the best prediction. Spatial tiling reduces sampling bias in your model when points are clustered. Highly clustered points can cause sampling bias by artificially inflating model accuracy scores. Under explanatory variables expansion, basis functions ensure the original linear is selected. Uh, Explanatory variables does refer to explanatory training distance, raster, explanatory variable expansions, original linear. Yes. Is checked, and then check the box for the following additional options: squared, quadratic. Okay, that's it. pair pairwise interaction, and then smooth step hinge. For apply special tuning, check the box. Apply special tuning, check the box. For minimum nearest neighbor distance, in the first field type 5. Okay. In the second field, click the down arrow and choose kilometers. Expand advanced model options. The relative weight of presence to background parameters should be a value between 1 and 100. 100 being the default. A higher value indicates that presence points are the primary source of information for training the model. A lower value indicates that background points also contribute valuable information. The proportion of background points to present points can significantly affect prediction results. Creating a prediction model is an iterative process that requires you to adjust the parameters, such as the proportion of background points to presence points, until you have a model that is suitable for your research. For relative weight of presence to background, leave the default value of 100. The training output section allows you to create outputs that can be used to review the diagnostics and reliability of the prediction model. You want to review this diagnostics, so you name the training outputs. Now, expand training outputs and set the following parameters. For output trained features, type trained features. For output response curve table, type curve table. For output sensitivity table, type sensitivity table. Expand prediction options. I don't know. The prediction options section allows you to create the output layers that show the baseline and future suitability for maize based on your trained model. The output prediction features is a point feature layer that will be added to the map after the tool runs and will show baseline maize suitability. Because you are using the baseline bioclimate variables as the explanatory variable for input prediction features, use prediction points. Input prediction features, prediction points. For output prediction features, type baseline maize suitability. If you are training the model, click the pause drawing button now, then click run. So you're going to pause drawing, then click on run. So click on run and allow it to run. Okay, so the tool has finished running with warnings. So let's view the warnings. Okay, so its prediction values for 813 of 512 to 513 features had to be extrapolated due to explanatory variables values outside of training data range. Okay, so that's the warning. So what next do we do? It said click. Okay, we should turn off the baseline stability layer, then save our project. Then step 4, we are going to run the prediction model. Okay, so let's do that. I think we'll end this one here. We'll continue with step 4 on another video.